tomorrow. We're just getting a little bit of background of what matrices are. A lot of times you'll see them show up on the ACT, and if you know just a little bit about them, you can usually get the questions, but otherwise it just looks a little intimidating if you don't know what a matrice is. So a matrix is really just an array of numbers. Okay, and it looks something like this. You have these bars, and you'll see numbers inside, like that. Do you need pencil and paper? Just watching. We can give the size of a matrix, and it is rows by columns. So when I'm looking at this one, the size, rows are horizontal, just like Google Sheets. A row is horizontal. How many rows does this one have? 2. How many columns does it have? So this is a 2 by 3 matrix. Okay, if I said this, what size would that one be? This one might be called a square matrix. Anytime the number of columns and rows are the same, you might hear it called a square. Okay, so a 2 by 2, a 3 by 3, a 4 by 4. Those are all square matrices. We also could have like a column or a row matrix. So a column matrix looks like that. It's just a single column. I wonder why that hasn't gone away. Okay, what would the size of this one be? We do rows first. There's 4 rows. How many columns? Just 1. That's called a column matrix because it's just a single column. What size is this one? And this would be called a row matrix because it's just a single row. So column, row, square, those are just special terms that you might hear to describe unique shapes of matrices. Does everyone understand the size of a matrix and how we get those? Okay. If 2 matrices are the same, that just means all of the corresponding entries have to be the same. So they have to have exactly the same numbers in the same positions. With matrices, we can do a lot of different operations with them. We can add, subtract, multiply, divide, all kinds of things. Today we're just going to look at basics, like adding and subtracting with our matrices. So, here are 2 matrices. Matrix A is this one, matrix B is that one. First of all, if you are going to be able to find the sum, so if I'm going to be able to add these matrices, they have to be the same size. What's this one? Rows by columns. 2 by 4. What's this one? 2 by 4. So that means I can add and subtract. If they weren't the same size, if one was 2 by 4 and the other is 4 by 2, you would just say no solution. We can't add them. Okay. When I say A plus B, I am going to get something of the same size. So it will have 2 rows and 4 columns. And if I just told everyone to guess on how to get this, I bet everybody would guess the correct way to add those. What do you think you should do to get this first number? Add the first numbers. 2 plus negative 3. we just keep going. So 4 plus 4 is 8. 8 plus 0. Negative 3 plus 1. All right, what's my second row going to be? Okay, so you literally just add corresponding numbers. Matrices are used when there's a lot of data and they're trying to keep it sorted. Okay, so a lot of times it might correspond to a system of equations and everything has a certain position, so you just add those positions. I also ask for the difference, A minus B. When you do A minus B, you also will get something of the same size. How do you think I get those numbers? Same thing, we're just subtracting. So, is A minus B and B minus A going to give me a different answer? Yes, with subtraction, order does matter. So A minus B. So 2 minus negative 3. 4 minus 4 is 0. 8 minus 0. Negative 3 minus 1. 0 minus 6. 1 minus 8. 2 minus 2. And 3 minus 0. All right. Is everyone okay with how I got this? Yeah. All right, I want you to do your own. Here is yours. Find A plus B and A minus B. All right, we can add them because they're both what size? 2 by 3. What'd you get for A plus B? Okay. And then A minus B? All right. Are those okay? All right, another thing we can do is what's called scalar multiplication. That means I can multiply a matrix by a number. So, 3 matrices here. The first thing I want you to find is 4A. What do you think you would do to find 4A? Take every number in there times 4. So first row becomes 12, 4, 20. Second row becomes negative 8, 0, 24. Size doesn't change. We're just multiplying those things. If I asked you to find 1/3 C, what do you think you do? Matrix C, everything times 1/3. So we get 3, 0, negative 1, 2. All right, we can do combinations of this. So the next thing I'm asking for is 3A minus 2B. So what do you think you do? Yep. So if I did 3 times A, I get 9, 3, 15, negative 6, 0, 18. So that's 3A minus 2B, so every number in B times 2. And then we just subtract. So 9 minus 8 is 1, 3 minus 2 is 1, 15 minus 0 is 15. Negative 6 minus minus 16 is negative 22. 0 minus 2 is negative 2. 18 minus negative 6, so 18 plus 6 is 24. Could I have done like 2a plus 3c? No. Why? They are not the same. C is a different size. Any questions about those? Can you guys try one? So you take everything in A times 2, everything in B times 7, and add those together. And we should get first row 28, 110, second row negative 16, 17, negative 26. All right. So those are the matrix operations we're covering today. The second thing I want to talk about today is solving equations involving matrices. So a lot of times a capital letter is used to stand for a matrix. So if I ask you to solve this equation, what kind of matrix is this one? It's a column matrix. Equals 4G. G here is a matrix. So we are finding matrix G. If you were solving this equation, what would you do to get G by itself? So I'm going to take everything in that matrix and divide it by 4. The size doesn't change, so we still have a column matrix. So we get 2, negative 3, 16. Is that one okay? Okay. How would I get matrix J? Yep, I'm just going to subtract this one over. So negative 9 minus 6 is negative 15. 21 minus 10 is 11. 18 minus negative, so 18 plus 12 is 30. All right, I want you guys to solve one. If you divide by 4, you just have to make sure you're dividing all of them. I would, so you could certainly do that. You'll have some fractions, or you could subtract this over first and combine those to start. So 24 minus 5 is 19. 31 minus 11 is 20. Negative 40 minus negative, so negative 40 plus 16 gives us negative 24. Now what do? Divide by negative 4. You can have fractions, that's fine. So we get negative 19 fourths, negative 5 and 6. Okay, any issues with those equations? Final example of the day. If, I'm not going to do this one, I'm doing a different one. Hold on. Okay. So this time I'm not asking you to find a whole matrix. I'm just asking you to find some variables. I've told you these two matrices are equal. If they're equal, all the corresponding parts have to be the same. So the first thing I see a 2a plus 1. What does 2a plus 1 have to equal? So that means a has to be negative 9 halves. All right, next numbers are the same, negative 2's are the same. 5b, what does 5b have to equal? 6. So that means b is 6 fifths. Then I have a c minus 4. What does c minus 4 have to equal? So that means c is negative 8. All right. Any questions at all? There is a Math Excel assignment open. If you have not finished yesterday's, make sure you get that done as well.